Hello everyone. Today we are going to associate major soil groups with the different biomes in which they can be found. So it's important that you're able to associate the type of ecosystem with the soil that is created. And again, climate is the #1 governing factor that determines both what biome will form and which associated soil is also going to form. So we have 5 major soil types. They are spodosols, alphasols, mollisols, iridosols, and oxasols. So the spodosol is the type of soil you find in like a boreal forest where you have a number of pine trees, and these pine trees, their leaves, when they fall on the forest floor, create an acidic O horizon. So you have that O horizon because you have a plant litter layer. Only this plant litter layer is composed of pine needles, and pine needles tend to be acidic, too acidic for other vegetation to grow. If you've ever walked in the forest and have noticed when you get into a piney forest, there's very little other vegetation on the forest floor, and that's because the forest floor has become too acidic for other plant life to grow, and the dominant plant species are those pine trees. It's actually quite easy to walk through a pine forest as opposed to others where the vegetation is thick. So anyway, a spodosol is something you find in a boreal forest. Now an alphasol is something you find in New York State, where we live. This is where you have a very thick O horizon because we have fall every single year, where the trees' leaves fall off from the trees and land on the forest floor, and that gives us an accumulation of a plant litter layer, a thick plant litter layer, and so we tend to have a good nutrient-rich A horizon, and excuse me, still working on that cold, and a humus layer where we get accumulation of that organic material within the A horizon. So an alphasol is associated with a deciduous forest like that we have in New York State. Now, how do we get to iridosols? Mollisol. Now, a mollisol is associated with a grassland. With a grassland, you have thick grasses. Our grasslands exist in the prairies, and this region of our country has been heavily converted to agriculture because of the presence of a mollisol as well as the topography. It's very flat there, which makes it easy to maintain crops. But a mollisol is actually a very good soil for agriculture because it tends to be loamy, which has a mixture of all the 3 main characteristics useful for growing agriculture. It is a very fertile soil. It's rich in humus, which is where all those good nutrients are stored. And again, in our country, the region where these soils are found is very flat. So mollisols have been heavily converted to agriculture, and these are associated with the biome grasslands. Now, iridosols, you can kind of assume by its name where you might find these, and that is in the biome of deserts. And deserts are very dry or arid. Now, you have a salty A horizon. All right, there's low precipitation, but what precipitation does fall evaporates and can leave behind precipitates known as salts. And these salts create a salty A horizon. There is no O horizon in an iridosol because there's not enough vegetation. Not only that, but the vegetation is very old. Cacti can live to be over 100 years before they die and release their nutrients back to the soil. So very nutrient poor. Very low primary productivity due to the very insignificant amount of plant growth in the region. And again, an iridosol is associated with a desert. Now, an oxasol is a unique case. There is also no O horizon in an oxasol as well. There is no plant litter layer. We'll talk about why in just a minute. Oxasols you find in a tropical rainforest. Now, when I think of an oxasol, I think, there's a lot of oxygen. Tropical rainforests have some of the most vegetation, therefore they're producing significant amounts of oxygen. So oxysol, lots of oxygen, and we find these in the biome of a tropical rainforest. Now, even though there's so much thick vegetation, the soil is actually very nutrient poor, and you do not get an O horizon. You do not get a plant litter layer. Now, that is kind of contrary to what one might assume when considering how much vegetation there is in a tropical rainforest. The reason for this is because as soon as a tree gets struck by lightning and a limb falls to the forest floor, or a single leaf from a tree hits the forest floor, all these little critters and organisms come out and they consume that organic material before its nutrients have an opportunity to decay. There are millions of different types of insects and scavengers and other organisms looking for any minute amount of organic material they can get, because there's such a diverse amount of species in tropical rainforests, and they're just thick with organisms. And so when a leaf or any organic material hits the forest floor, it's consumed before it has an opportunity to decay by all of the insects and scavengers and whatever else is in the tropical rainforest, eating up that organic material. So it doesn't have time to release its nutrients back to the soil, so you end up with a very nutrient poor soil. And that is it for our 5 soil types and the biomes in which they are found.